The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Welcome to the final competition. So you guys survived this far, and I don't know how. I think probably with very little sleep, and knowing all the emails that I have seen and all the check-ins. I think I don't know how many people had who had any sleep within last 24 hours. Oh, okay. Okay, and also what we looked at was the quality of the results keep improving because he was running tests to check what's going on, and when you move to a machine, the things ran very fast. We're like, wait a minute, why is it running that fast? Because people have checked in more and more fast and faster versions. So things improved not because we checked in faster machines, but you guys actually did a lot of work. So. First, before we get started, I want to thank Akamai. So we are in Akamai, got this nice place, and then we are going to get a demo and going to have a party at the end, sponsored by Akamai, which is really cool. So you guys actually see something what the real life people who care about performance do. So it will be really fun. And also, I also want to thank most of our MIT passes that helped you guys a lot in meeting with you individually. So we had people from Akamai, LSM Digital, Google, Lockheed Martin, MathWorks, Vertica, VMware, and a couple of independent consultants who basically put a lot of their sweat energy into helping you guys.
And Microsoft.
Oh, and Microsoft. Okay.
Okay. So let's give a hand for the posse, MIT posse, and the companies that sponsored them.
Yeah. So here's the process we are going to do today. Today is about the competition. So we set up a very strict set of rules that we are going to go through, which is not going to be the way we are going to grade you guys. So because we are going to be a little bit more lenient. So this is the set of rules we are going to do. So we had a lot of these images that you guys submitted. And some images were not exactly same. People did little bit things. The images looked a little bit different. So what we said was, instead of we deciding, we will let you guys vote on images which can participate. Okay? So don't be harsh to your friends. So what we'll do is we'll first go through the images, and then you guys can say which images should be part of the competition. This is for the competition that at the end that we'll get the Akamai sponsored prize, not for the grading purposes. So the fact that the image is not counted doesn't mean you get 0 in the grade, but you won't get to participate in the competition. So after that, what we have done is we looked at all your projects, ran them on our 12-core machine, and we will show you and seed them. We'll say, here's the order everything happened. And there are there are some basically what we'll do is we'll probably pick up the top set of seeds in there, because we don't have time to run through everybody, and basically run these things live on our 48-core machine. And then the accepted image that run fastest, get generated fastest in the 48-core machine wins the prize. Okay? So that doesn't mean that when you start grading, we will look at all the images and we will do some averaging. We will do a lot more fair. But hey, this is a competition. We just need to find the top guy. And so we have a top group. So we have a much more faster thing. So to get started, so here are some of the images people generated. So what we want to do is show a reference image. That's the reference image. And what we'll do is we'll fast go through everybody's images generated, so you'll get a feel for all the variations out there. And then after that, we will go ask you to vote. We will ask you if you don't want that image to be part of this. We'll see. Okay, so this is the reference image. Why don't you go through the Charles, Mike? Yep. Just why don't you go through the rest of the images?
Okay. So before we. So before we get into the images that that we actually rendered in the last few hours, I just wanted to honorable mention for this. I think this is the coolest. I'm sure you guys have been looking at a whole variety of broken ray tracer images, but I think this is pretty much the coolest thing I've seen. So honorable mention for that. And so now let's look at things that people actually submitted. We're just gonna first we're gonna go through all the images and sort of look at the range, and then we'll go back and vote on them. And so I'm just gonna flip through the ones on the right and give a couple seconds to each.
So see whether you can identify the artifacts.
You gotta say when you're going, because otherwise people aren't going to realize that you've been through 3 of them already. Okay, here's image 1.
Image.
And here's the next one.
Image 2.
Well, that's 5, 4, 5.
Well, but some of them do.
Image 3. Image 4. Image 5. Image 6. 7. 8. 9. 10. 11, 12, 13, 14, 15. Okay, 15. There were some groups that we could not get the render. Either it crashed or after 10 minutes it was still haven't produced image. So they are not part of the competition. Of course, we'll run them for the finals. Yeah. Okay, now the vote time. Okay, so this image, in or out? Who thinks out? Whoa, you guys are a harsh crowd. Okay. That
Who thinks in?
Who thinks in?
Gotta get you both. Who thinks in?
So we know who.
Okay.
Who image is that? Okay. Okay. That image is out. Okay, you can take notes. Okay.
Yeah. Do you want to write down the numbers of the ones that I described?
Okay. Next image.
What one is that?
Okay, this one. In or out? Out. Okay.
By the same.
Okay, it's out. Okay.
It's got the funny ring at the bottom, which I guess that's what most of you are picking up on. I think that's kind of disqualifying for the derby.
Okay, how about this? Out, in or out? Out. Whoa.
Wow, you guys are vicious.
Exactly. Okay, how about this? How many people think this should be out? Oh, okay, that's that little gaming here, I guess. Okay, that image is in. Okay, next one, in. Ooh, something. Okay, how about this one? Who says it's out? Okay, who says it's in? I think it's I think it's in.
So the issue is look at the water.
Water.
Water has holes. That's what's going on. The water has holes here. Okay?
Yeah, that's the only one I'm going to be able to reference later.
Okay, so what's the decision,
So
Charles?
let's vote again.
Okay, let's vote again. Now
You have to point out what's going on in the image.
Yeah, I think we should. I mean, do we want to get people to like say why they think it's in or out, or I mean,
No, well, yeah,
so then
it's helpful to say what's in the image, though.
yeah.
Okay, let's take a vote again. How many people think it should be out? Okay, that's out.
Okay, yeah.
Okay, next image. Number 5. Okay, in or out? How many people think this should be out?
Is there any problem?
No, I mean, I don't think there's a problem. Okay, yeah, we just okay, good. Next one. Okay, how many think this should be? Okay, that's unanimous. That's out. How many think this should be out? Okay. Okay, I guess that's in. Is there another one?
Yeah, I think it's interesting to flip back and forth and see the difference between these two. Like, these are very close, right?
Yeah, but it's obviously using this one.
Okay, how many people think this image should be out? Okay, that group is going to kill everybody. So, okay, are we done?
No, I think.
How about this one? How many people think this should be out?
There's not enough caustics. You don't see the floor. Like, I don't know.
Yeah, that's an interesting point.
Almost no caustics in the surface and almost no caustics.
I mean, we've let slide the ones that
How many
look
people
the
think it should be
same.
out?
Say what? Sorry.
We've let pass ones that look the same. So
Yeah. Okay, I guess.
we're just becoming more about
That's not-
surface as time goes by.
Yeah,
Okay, I
it's
think
really
we
not
will
fair.
keep this in
When you have a good
because-
image and then you have a bad image right after that,
Yeah.
it's not fair.
This is the one.
I mean, we will keep this in because there's few people voted out, but it looks pretty cool. Okay, next image. Okay, how many people think this image should be Okay, that's a clear out. How about this image? It's fine. Okay. Anybody want it out? No. Okay. Good. That's in. Next image. How about this image?
No.
Okay. Yeah, exactly.
We really should start a reference.
Image on the other side to see how many people vote that out.
Two identical images and people can be voting it.
So, okay.
Is there any explanation why all of the yellows have been so far different from the reference image?
All
From the book?
So, I guess this image is in. Okay, next one. How about this image? Fine. Okay. Anybody want it out? No. Okay. How about next one?
Okay, this is. Yeah. This one has some.
It looks pretty good.
It's pretty good.
It's messed up on the left and on the right.
Okay. How many people? Okay. Well, they have to count this one. This is too close. 1, 2, 3,
That's
4,
probably
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 out. Who says it should be in? Oh, I guess it's out.
Oh, the number of the MS happens to be.
Okay, that's it.
That's it. Okay. So now, next thing we are going to do is we are going to show your rank in our seeding.
Yeah, so we seated you guys on the 12-core machines. And, okay, so we seated you guys based on the time that it took for scene 3 on the 12-core machines. So here is the ranking so far. Top one is #1 team. And we ranked about the top 10 or so.
So you show the run time.
I don't have the run time actually for the scene.
For scene 1?
Yeah. Actually, I can get it real quick.
You had the graph, didn't you? So here are the rankings of the top 10. Do you have that graph?
What? I don't have a graph.
You have the numbers.
I just have the numbers. But
Okay, why
there are
don't-
all
why don't-
kinds of other numbers too.
Oh, it should. Okay.
Unless I unplug this.
No, you can. You can't. Nobody can see it. That's it. Okay.
Do we want to get the rankings?
Okay. No. Then now what we are going to do is we're going to start from the bottom and start running it on the, our 48-core machine. And while it's running, we want that team to say a little bit about what they did to get their performance. So
We need to knock out
we gave
the
them
ones
option
that are,
yesterday. Either come prepared to give a 4-minute presentation, or make your image run very slow, so you don't have to. So I guess.
We have to knock out the ones whose images did not render.
Oh, that's true. That's
Okay.
true. That's true.
So maybe they all get knocked out, and then everybody goes home with an iPod.
No, or nobody.
There we go. Now we have time for everybody.
Okay, there we go. So this is the time times for all the images. So is there any of these images getting knocked out? Can you check that?
Yeah.
Which images get knocked out?
So I'm looking at them from bottom to top. So this is, I think this one's knocked out. This is
#1, 2, and 3.
So wait, what?
First 3. What are the first 3 images?
Well, I don't know. It doesn't matter. I can just. So I think the David Lamb and Victor Wang got knocked out because this is their image here, and
Yeah.
Okay, that got knocked out. Okay, the last image got knocked out. Okay.
and then who's the next group?
What's the next group? Which way?
Slowly. There it goes.
Okay.
This one was the water. Yeah, 19.
Yeah, that was.
Did you choose to get rid of that? I think so. Yeah.
Oh, oops. Uh-oh, they're getting knocked out. Okay.
This is
I'm gonna have like 7.
The thing, right?
Okay, that got knocked out too.
Yeah, that's
Which one is that? Oh man, no, it is. Yeah, we have nobody competing at this point.
I think we're too harsh.
That survived. Push. We have a survivor. Okay. So we might be like there might be a knockout by default. Oh, that is out. Oh man. That survived. That survived. Okay, at least we have 2 people survive now. Okay.
No, that was not the one that was really.
This is the one that was sort of darker.
It's like they don't have enough.
Yeah, but
this one's kind of. You guys didn't vote it out though. Right. So here's the 2 reference images.
yeah, if we didn't vote it out, we can't vote again.
We voted out.
No, we didn't vote out.
Some people voted against it, but I don't think.
Yeah, but it didn't get a quorum. It didn't get a quorum to get voted out. Majority.
But we're getting.
We just said we were
I
going
know. Okay, how about other 2? First one. Let's look at the other.
Who's it? It's.
We use scene 2.
Okay, that survives. That survived. Okay, good. Okay, Mangpo. Okay. That survived too. That survived. Okay. Li Chang.
Oh yeah.
Oh. Oh man, that's okay.
Competitors.
Yeah. So that is a knockout blow there. Okay. Okay. Now what we are going to do is we are going to run it on the from 48 core machine from the bottom. So we will let other teams also, if they have time, to come and explain what they did. We are running. Who's now?
This is Dubs.
Dubs. Okay. Why don't you guys explain what you did? Come up here. Give the mic.
I think the mic is off.
The mic is on, but it's only for the video.
Video. Okay.
Not for us. So you have to use the mic, but you can't hear the message.
Okay.
Okay, so we parallelized the ray tracing part, the 2 for loops for going through all the pixels on the screen, and then we parallelized the main loop for caustic illumination, and then we changed the sort of the data structure, how that works. Use some like bounding boxes to make the intersection faster. Yeah.
Okay.
I don't know what else we did.
We found ways to get rid of.
Mic, please.
Mic.
We found ways to get rid of trigonometry, and which actually helped a lot. And we got rid of the recursion in locate photons, which was the major roadblock. So.
Question.
Sure.
How did you get rid of the trick?
Repeat the question.
How did you get rid of the trick?
They were converting from XYZ coordinates into spherical coordinates and then back again over and over. So we just didn't do that. So yeah. Yeah.
Wait a minute. That's the.
It could be.
That sucks.
Slow down. Yep.
It's slowed down.
No, the seeding was done on scene 1, right?
Oh yeah.
Yeah.
Okay.
Wait. Apples and oranges.
Wait, so
I just ran scene 3.
that's on 48.
Yeah. 48 code. Scene 3.
So there might have been a slowdown.
No, but this is scene 1 is much more simpler. So okay. Good. Okay. Good. So you're on the board now.
I have a question. How are the seeding being done in scene 1 if it doesn't have like the surface the display surface caustics? And then you it might be that some people did really fast on that one, and
because we ran everybody's scene 3 and we guaranteed that the top end team survived.
I agree.
The results are rigged.
He didn't say in the tape. Okay, good. Okay, good. First team is in, and then the next team. Elizabeth. Yeah. Scott. There we go. So while that thing is being run.
All right, so I guess for the display surface, the main optimization there was imagining 2 planes at the top bound and bottom bound and seeing if a ray passed through them, and then only checking that section of the grid. And then even within like that square bounding box.
Yeah, like if there's a square and then the ray is going through like that, there's a bunch of grid squares. Yeah, like if a ray is intersecting a square, there's still a bunch of grid squares above and below it that you don't have to check. So we kind of imagined it as projected it onto a 2D surface, so we didn't check additional superfluous grid squares. Yeah, we also did the thing where we got rid of the trig by transforming from polar coordinates to XYZ coordinates. Although before that, we used a fast sine and cosine approximation, which was almost as fast, using a quadratic curve, which was kind of cool.
Those are the main.
Yeah, we did an SSE matrix multiply, which barely speeded it up, but whatever. We moved stuff into util.
Is you are the team that had issue going to Intel to AMD?
Well,
one
yeah,
team.
we were complaining about.
Oh,
okay.
Okay.
Yeah, we didn't have any issues.
Intel, a
like
certain
it.
SSE instruction is not the same in AMD, so nice for.
Yeah. You wanna?
Yeah. Good. Okay. Good. Okay, so we are waiting for the time to come.
So we ran it once, but we forgot to time it.
So, by the way, I want to give a chance for the top team that get knocked out to explain what they did, even though they are not in competition because they ran much faster in the scene one. Who's the top team? Who's the top team out there? They're not here. Oh, okay.
Not here.
They're getting sleepy.
Okay, 59. Oh, now we. Oops, no. Okay. So, yeah, inversion of that. Okay, next team. Okay.
So our team also did a Centric that was done in the previous two teams. We got rid of the trigonometry and also used the bounding box, basically described in the previous team. And we also tried to use SSE, but as soon as the news about the AMD machine, we got rid of that.
Oh my, look at that speed. Whoa! Okay.
If you want to take more time to talk.
Yeah, you
I'm
can.
sure you
Yeah.
guys have some things that are different than everybody else. In fact,
It's for recording.
So for the iCache, I use like a three-dimensional grid because I realized that the R0 times the tolerance is like usually 1, unless there's some outlier, but I don't see one in my case. So I use a three-dimensional grid. I use a lot of logs to prevent contention. So I do the same thing for photon map. I basically like implement my own photon map and I just get rid of theirs. And also same thing like using a grid, and I spend a lot of time debugging.
Yeah, and we also do some minor optimization, like we implement the render class as a reducer, so that we hyper object, so every time steal some other's job, it will create a local view of the render object. And we found there is a artifact that because we are seeding the render object as the default seed is 2, right? And it will create some artifact in our image. So we use a render number to seed that render object. That's what we do. And also we do something like we change the we don't have locate photon. Yeah. Yeah. Okay. So we have done a lot of things to improve the original photon map, but after that we decide to change our implementation of photon map, so we don't use that. Okay, and some other things.
Okay, good. Thank you. Okay. Okay, the suspense is on. So the final team. Okay.
So one of the first things that happened is that we looked at the code and like it was all like KD tree, and we're like, what's that? So we got rid of that immediately and we turned it into something. I think the other groups might have talked about it, but we gave it a nifty marketing name. We called it a photon cube. And so we created lots of these. We partitioned the large like cube environment into many small photon cubes, so we could just like jump in and like look in the relative like air vicinity of photons that you're looking for.
Yeah, so basically it's like when you do locate photon, you know like the reference photon, and you can create a sphere. So we can like do constant time to find like the boundary of the photon cube, like from like x1 to x something, y to y, and z to c. So then we don't have to like traverse the tree, and we basically parallelize two parts. So the one in render and another one in the trace photon, that when we try to put the photon in the map. And also like when we create a photon to the cube, we use vector to store the photon in each cube, but then it's not really good because when you put the photon in the cube, you have to like new photon, which means that like the memory is like spurts throughout your program. So like after that, we like convert that into like a block of memory, and we use that when we call locate photon.
Okay, and for the last about surface that intersect, and there were like 4 kind of optimizations. First one is checking whether if the origin of ray is outside of the maximum bound and lower bound of surface, then and check whether y direction is toward outside, or if it's toward outside, then we don't have to check, just return false. And second thing is like the square cube thing. Like when ray intersect, we can make a boundary by directly mapping to the XYZ of the at the surface, at the maximum boundary and lower boundary of the surface. And also, when you iterate through the X index, we can cut off again with because like a bitmap, we only have to check with Z indexes, which correspond to Ray's Z index at that cube, at that X location. And the last thing was done with for each square, we pre-computed the minimum value and maximum value of Y, and we compared with compared the Ray's Y value within that range, and we just cut off if it doesn't intersect, it doesn't overlap.
Okay, good. Okay, now this is the suspense part. Okay, we are going to run this and see. The time to beat is 18.7.
Okay, I can run it again.
Okay, run it again. Okay, there we go. Let's see. How many people think it's going to beat 18.7? 18.6. Okay.
9.
Exactly. Keep counting. Okay, yeah, there we go.
13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25, 26.
Oh, okay. It came out as 26.41. Okay. So, you guys are the winners. There we go. Come up here. Where's Daniela?
Danielle disappeared.
Yes, she did.
Okay, let's see whether she can find her. So, okay, just hold on a second until.
Yeah, there you go.
Yeah, that would be great if you can find her.
Just to compare the winning reference.
So yeah, you can't vote it down now though. You can't look at the image and say, no.
So this one's the reference.
Put it next to each other. Oh, that's better.
Which one's the reference?
This one's the reference.
If you can tell that.
Right.
I think they're not aligned. Can you align them better?
They're not aligned. But
There we go.
Okay.
There
so
we go.
have a winning team. Daniel,
We have a winning team.
Yes.
And so it's my pleasure to introduce Danielle Smith, who is the University Relations for Akamai. And she's here to give you guys your prize. So we have 3 winners. There you go. Yeah.
Okay.
So no, thank you. First of all, welcome to all of you guys for coming, and you know, we wanted to give you these prizes. So we have some cool iPod Nanos, which you may or may not have already, but it's, you know, it can't hurt to have another. So yeah, they kind of, you know, burn out or you lose one or somebody steps on it. So. Congratulations, you guys have worked really hard. So.
Congratulations. 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 Okay. Okay. So what's next? Yeah, that's it. You're done?
Alrighty. So, so we have plenty of food that's going to be right out in the atrium. I know that's the most exciting part. But it should be arriving in the next 10 to 15 minutes. So we have a few minutes. I thought maybe this would go a little bit longer.
Sure.
So
Okay, we have a couple of things we can chat about, and then.
yeah.
Okay, sure.
So just a couple of housekeeping things. If you need to use the ladies' room or the men's room, it's actually right outside that door, out the double doors. You'll see it right there. I have invited some other Akamai employees to come and mingle and say hello to you guys. So I encourage you, if you see any faces that aren't familiar, to kind of go up and talk about your projects and introduce yourself. You know, and thanks for coming. I know we wanted to switch it up a little bit because it was the last class. We wanted to get you out of the classroom and just kind of shake it up. So I'm glad you came to join.
And the knock tours.
And the knock tours, thank you. So on the back of your name tags, there's a number, 1, 2, or 3.
No, that was.
1, 2, or 3. So that correlates with the knock tour that you're going to be on. We have to keep it to relatively small groups. So the first tour will be at 10 past 4. The second one will be at 4:40, and the last one will be at 5:10.
I guess if we don't have too many people, we might be able to compress something.
Yes.
The first tour,
Yep.
yeah. So we'll see whether we can compress that.
Yeah, so I'll just call the the first tour, and you guys can go down. And obviously, it's optional. You know, don't feel if you're not interested, you don't have to go on the knock tour. So I think that's it. So
Good.
thank you.
Thank you.
Okay.
We can talk about a little bit. So one thing, we are trying to get HKN feedback up to hopefully 90%, and we are right now at what, 11?
No, we're a little bit higher. We're now at about 16 or so.
16. So there's a little more way to go from 16 to 90. I hope you guys go back and fill out this survey. It's very important.
Please take a few minutes to do that. It really helps us in, even if you want to say bad things, okay? It really helps overall to give feedback, and the department likes to see these things. Oh, yeah, thanks. Likes to see you know, how it is that people are responding to the courses. So if you hated the course, if you liked the course, in particular, we have some questions on there that are specific to how we teach the course next year. One of the ideas we have for next year is to introduce recitation sections, which would focus on the use of tools. Okay, so basically the conceptual stuff, much as we have the lectures now, but then also having something where it really takes you through each tool and teaches how the use of those tools, which would be taught once a week. So if you think that's a good idea, that's going to really help to have that kind of feedback, and it will certainly help the students who take it next year if we can persuade the department that that's worth staffing the sections next year. Also, if you have any positive things to say about teaching assistants, that's a great place to put it, okay? If they helped you get through this term, you know, this is a great place to say thank you, and it only takes a few minutes, Okay, so I'm sure that some of the TAs put in more than a few minutes, okay, on your thing. So that to take a few minutes and say thank you on that form would be, I'm sure they would very, very much appreciate.
Yeah. One thing, as Charles mentioned, what we are trying to do in recitations is do a little bit of programmer life skills. So I know all of you guys are probably very smart, can think about complex algorithms and stuff like that, but there are a lot of tools that it's not the smartness that you can spend hours trying to figure out, but if you know it, it would be useful. So what we are trying to do is have these recitations to say, okay, how do you use a debugger? And even how to change a makefile, things like that. So one thing until the food arrives, I'd like to see is get some feedback saying, okay, what is a tool you'd like to know or like to learn, or something you think is very useful for people coming next year to learn, that if you have spent a lot of time worrying and you think you will spend way too much time trying to understand, it would be easier for us to think about that. I mean, I would like to get your feedback. And also probably will open up for some general feedback on class.
I don't know if you want to repeat that, but yeah, if a more in-depth thing on how to use Git would be really useful. Okay. Because I know it has things to make your life easier, but I don't know how to use any of them. So
yeah, we ended up always breaking the branches, and it's like, yeah, we maybe know how to do this, and it is really easy. And then we like use this git command, and it's like, now your branch is broken.
Yeah.
Good. So Git.
Yeah, I mean that's because those are the interesting tools, because if you know everything right, you can do a lot of fun things. But if you do it wrong, you end up in a huge mess that all your source code all over the place, and you don't. So yes, I mean I can relate to that.
If you use Git correctly, if you know how to use Git, if you learn how to use Git, you will find yourself using it even when you're working on a one-person project. Git is awesome. I can highly recommend learning it.
What would be helpful is that telling us that you're running it on an AMD box and AMD doesn't support SSE 4.1 instructions.
Yeah, I mean, this is supposed to be x86 compatible, all those things, but I mean, some people learn the hard way that, okay, the world is not the same, even though.
But that is part of the lesson of the course, is how do you make high performance portable? Okay, and so what you choose or don't choose to use, you know, but I agree. It's.
I mean, that's why we want to run it the night before, because we knew things like this will happen, so we can at least give some time, say, okay, look, go change something. Were you able to fix that? Oh, okay, good. So yes.
Good.
And sometimes the problem is a lot of these small changes you don't know until you run into it. Like then said, oh, somewhere in page 256 in the manual that there's a footnote, say, oh, by the way, and that's what happens in there. So it's I mean, if you have to list everything, there'll be probably entire encyclopedia of things that you have to say.
So one other thing that people ask about is what comes after this course. Okay, so next term, Saman is teaching the compiler course.
Actually, Martin is teaching
with.
compiler.
Are you teaching with him?
No.
Oh, you're not teaching. Okay.
I
thought you were.
Yeah.
Okay.
Yeah.
So in any case, compiler course is a good follow-on course. For those who haven't done 6046, that's a good course, and I'll be teaching that course next term. In addition, how many people here have done a UROP? Yeah, a few of you. So let me encourage you to look for UROPs. You now have some skills that will make you really valuable. And in particular, my group is looking for probably 2 more UROPs than I have already. Already Boone is one of my UROPs, started just a couple weeks ago. And so we do have some other projects in both architecture and in software-related things. And so if you're interested, if you go to my group's webpage, it tells you 5 things you have to submit if you want to work in my group. Okay, that include things like samples of your code. Well, you ought to have that by now. Okay, and so forth. So let me encourage you to do that. And Saman also has active participation of UROPs in his group.
Yeah, so Mangpo is already started doing a project in my group, and I'm also looking for a couple more people to do some compiler, runtime system, and a bunch of high performance type projects I have. And also for future course, one course I want to also mention is this IAP. There's a course that is done with collaboration with VMware to look at how to build scalable large systems using the Spring and Java platforms. So if they're interested in trying to see how instead of running on one machine, it runs something that can scale up to hundreds of machines, if you have ideas of creating a nice Web 2 interesting thing, here's an opportunity to do that. So if you're looking for interesting summer parts, IAP courses, this is great.
Yeah, I really encourage every single person who completed this class, okay, to to do a UROP with somebody before you leave. It's really a way of integrating your knowledge, and it is one of the most valuable experiences that you can have at MIT is to do a UROP for a professor and get involved in the research of a group, because it's in some ways it's like this course in that it integrates knowledge from a lot of different sources, okay, and it isn't just one thing. But even more than this course we still are dealing with artificial things, and in the research arena you're dealing with real problems. So let me just once again encourage you to spend some time getting a UROP, or and certainly looking for AUPs and MEng. How many people here are looking at MEng as a possibility? So fair number. Yeah, that's good. That's great.
So
that's great.
I want to add to that. So these days there has been a big philosophical discussion saying, why do you have to have universities? You go to OCW and sit home in your bedroom and you can follow all these courses and you don't have to pay MIT tuition, and wouldn't that be good enough? And why one part is not good enough is this class. So think about it. You can't go get the OCW catalog and have this kind of a dynamic. There's no 7th floor hole in OCW when you have a problem to go and get motivated. So that's one part of that.
John or
exactly.
Reed or Eric or Josh to to respond quickly about what's going on.
So that's one. But I think one other thing that a lot of people miss when they look at all the curriculum and stuff like that is the UROP ability. So a lot of these people, that is something it's very unique to MIT, and a lot of people benefit hugely with UROP. I have had UROPs who started with me as a senior. By the time they are graduating from with their MEng, they have 2 first author papers in the best conference out there, and everybody thinks when they say they are looking for a job, they are finishing their PhD and looking for academic jobs. No, they are just finishing up their masters. And I have had a couple of students that managed to become a really expert in the area by being a UROP. So they are not finishing up at MIT as a generalist saying, I can give me a job, but you're finishing up as have some deep knowledge in some area, at hitting and at the same level as most PhDs or most really like deep practicing engineers in that area. So that level, even if you don't do that, just seeing what happens in a research group, participating on that, having that pushing something to the maximum limit. In a class, there's a limit. We are not, even though this course is somewhat open, says make it run as fast as possible. But most of the time in a class, it's like we give you something. If you meet that, okay, you are done with it. In a research, there's no limit. You really, really push your boundaries. What's that?
Yes. So what do we have here, John?
I counted in my mailbox how many messages came from 6172 staff, and it's about 3,500 over the course of this term.
Wow. So this is also, as Saman mentions, a programmer life skills course. And one of the things that you should get used to in life is thanking people who help you. Okay, I think that all the MIT Posse members, all the people who volunteered their time to help you, okay, could really appreciate an email that says thank you and what exactly you feel you learned from them, okay? Because it's one thing to just say thanks, so long, etc. In addition, these people are contacts part of your network, okay, of understanding, what the world of software developer is all about, and can serve as useful contacts to keep. How many people use a service like LinkedIn or something? You probably all mostly use Facebook. Anybody use LinkedIn at this point? Okay, so many professionals use. I don't want to pitch for LinkedIn, but it is one of the services that that lots of people are on. So what are some of the other services that people use for professional contacts?
LinkedIn.
Yeah. So good idea to start connecting and building a network of of people who you know and who can answer questions for you. Okay, such as, gee, I'm considering these two kinds of job offers. What should I be looking for? It might be good to get a professional software engineer's input to that. Okay, because you know these folks. You've had a few meetings with them. Okay, and they know you, and they may be able to say, here's my take on that, as well as getting input from your family and your friends and your professors and your and other people that you know. But I do think that it's courtesy, it goes a long way in life, and they really have these are all people, as I say, who spent time looking over your code, and you should have heard some of the comments we got from them after Project 1. Oh my God, they have a single letter variable names for the whole thing. Or, what are you teaching these students? And I said, no, this is exactly why we want you there. Okay, so I think that if you feel, in particular, whether or not you feel you got anything out of it, okay, but in particular, if you did get something out of it, it would be a really good idea to not forget to send some email off to thank them.
Okay, we want to get some feedback from them.
Sure, yeah.
We have open mic.
Open mic?
Yeah.
Actually, open mic, let's do it like this, because I think it'll be easier if, and better for the video, if we just have people come up and...
and that might be, I don't know, this is going to be too intimidating.
Yeah, no, that's okay. They can handle it. These are seasoned... So comments about the class system.
How we can improve? We really like to hear that. I mean, things you like and didn't like. Like, for example, these absolute gradings we did for projects, I mean, had passionate support and controversy before. I mean, did you guys feel giving the top mark for the fastest and having at least a log scale? No, we didn't do a linear scale going down. I mean, was it motivating or demotivating? I mean...
So what do people think was the most valuable thing out of the course? I've had dinner with a few of you, and you were very opinionated over dinner, okay? So I don't mind hearing those comments again, but making them, for other people. So I know it's intimidating, but what I want to do is get a line. As one person's talking, I want other people to line up behind and just give us some feedback.
Come on.
Okay, come on. Who's brave? Yeah. You got halfway out of your seat. Yeah,
come on.
I'm sure you have an opinion. Who here does not have an opinion?
Sure, yeah.
Okay, come on. And
yeah,
good. And then you can line up right. There you go. Okay, there we go. Yeah. And then others can come up behind as they're motivated.
Good afternoon. First of all, I'd like to thank the professors and the TAs for this opportunity. This is absolutely wonderful. And all the students I worked with, you were all great. I just wanted to say, when you were talking about what the most valuable thing in the class people thought was, I don't even know how to pick. Of the projects that we worked on, that they worked on, I looked at everyone and just thought, what of the content of this project have I used just in the past year? And the amount of stuff that I've made significant use of that you guys covered has been at least 75%, maybe even more, of the material of the class. And that means that if you look over multiple engineers, you'd probably pretty quickly get coverage of 100% of it. All these projects, profiling, parallelism, algorithms, bit hacks, these are all things that I use on if not a daily basis, then a weekly basis.
Okay, good.
Thanks. Thank you.
Thank you.
So for me, I really had no experience with C or C++ or really distributed version control before this class. So a lot of my time, I think, was spent kind of learning the basics of, well, I spent a lot of time initially learning the basics like point arithmetic and that kind of stuff, and then a lot of time learning like the profiling tools. So I really do wish more time was spent kind of like a recitation. I think would be a good way to really get that out of the way, because the algorithmic stuff was more easy for me, which I thought was kind of ridiculous, you know, like the fact that these tools are what's holding me back, and like that I have to spend a lot of time learning.
So this is actually something very interesting people have observed. So if you do a physics problem set or math problem set, if you run into an issue, after a certain amount of time, you will just go ask somebody. But in programming, people seem to go on and on and on trying to debug this simple thing. And part of that, as a part of we try to get, is also not just all the cool algorithms and stuff like that, to give you a process. Because a lot of times when you start saying this program is slow, what do you do? And I think there's a missing part sometimes about process of debugging. So if the program doesn't work, what do you do? Where do you start? I think that's why we are trying to do a little bit of a basically this life skill. Say, okay.
It was great to learn, but if it was more structured learning,
so
that's
what we are trying to do.
I'm not as willing to ask, I guess, as a lot of people, so it's hard for me to.
So one thing we will try to do is probably
that's great feedback.
Yeah, we will try to formalize next year the 7th floor lounge. So because a lot of people who came there benefited, but have it a little bit more, and also get a little bit more life skills type things early on. Say, okay, look, if you find a problem, what will happen?
It took me a lot longer than that.
Yeah. Well, so that's our goal, is to
Yes.
make it so that people come up to speed more quickly. In some sense, another goal that I have here is next year is that the C students will stay in the class. Okay, so what happened is most of the C students dropped out. So, so in case you want to know, most people are going to get A's and B's. Okay, so most of the C students dropped out, and I would like to have people complete the course, you know, even the C students, feeling that it's useful to complete the course.
So I think, again, as the person before me, I learned a lot. I hadn't had almost any experience in C or C++ before the class. I had some experience with Git, but like I think that the class has a lot to offer. There's like a lot of content covered, and I wish that, for example, there are things that like I wish that I could have learned more about to how to implement in a formal way, like things like SSC instructions. Like, so I feel that like there was like a clear cutoff of like people that had a lot of experience, and they could be like, okay, you know, I know how to do assembly, I know how to do all these things, and if I want to optimize these functions, I can whatever write it down, and then I might like say. Then these are other people that don't have that much experience that, sure, like in class they mentioned this is how you use, I don't know, SSC or compiler optimizations, but it's kind of mentioned but not really got like really more in depth, or like this is a case of like how do you actually do this in real life. Like, I mean, I think maybe the examples given in class were useful but very superfluous. Like, you don't really know, like I know that like I was looking through other projects that were similar to ours for the final, and I think it's a class that you taught in IIP. There was a team of people that did a ray tracer in the multi-core programming, and they used SSC, like CMD everywhere. Like they packaged everything in. But you know, that's something that I said, oh, that'd be really awesome to do, but I have not even idea how to start doing it. And I don't know. So I think that there's still a lot of room to actually apply the concepts that are trying to be taught.
I think it's our intention actually to increase that part of the course, the data parallel part of the course, which I think we'll be able to do. You know, one of our concerns about adding material has been, okay, that means you guys have to learn it too.
Right.
Yeah.
You know, so you know, but I think that if we're able to reduce the workload of the learning of the tools by having recitations, we then can look at adding other material, because you know, and expect that the load on students won't go up.
Right. I mean, even what I want to say, it's like it's not even adding material. What I think it's like, I feel that I was going to class, learning all of these cool things, and then I was looking at my project, and it's like, well, these are the things that I know how to do, and I know that they mentioned all these other things in class. I don't know how to make them in my project.
In your project.
Yeah.
Right.
So yeah, that's
good.
basically.
So
great comment.
So I think one thing that both good and bad about this class is what happened in, I think it's applied to all of you, when you try to teach computer science. You get people who are, for the first time, they are writing any piece of code more than 20 lines. And you get people who are checking in code for Apache. And you have that entire range of people in the class. So how do you teach to everybody? And a lot of times when you give a fixed project, Either somebody's completely struggling to finish that, or they are like, in a day it's done, they are like, so what's this, what's new in here? Thing about performance is, as a lot of you figure out, there's no end to it. And you can keep doing it, you can do it more, you can do more deeper. So one thing about this class is I think there's something for everybody in that. So if you're struggling still, if you're learning, you can still get to some place, learn a lot. But if you have done that when you are in the 4th grade, you can still go and do something more, push that. So we try to keep that balance in there. So we don't want to bore anybody, and also we don't want a lot of people dropping out of the class either.
So continuing on what other people said, I also ran into the same problems with just the syntax, just the tools. So I guess I will start off thanking John and Reed. They're really fast and good at what they're doing, and I feel like I've asked a lot of dumb questions, and they're good at answering those.
John and Reed and Josh all took the class last year. Okay, and it's amazing. If you ask John how he did on the final project, didn't do so well. Okay, but it's amazing. You'll discover, it's amazing what you guys are going to learn next semester after being out of the class, because you're on a path to learning this stuff for yourself now. Okay, and you'll find that in all kinds of things that you do, that all these skills, you can keep building them. We will definitely be looking for TAs next fall. And so people who are interested should, who are going to be MEngs should, and even if you're undergraduate, you're still allowed to work hourly for the class. In fact, that's what John is doing. So if you, if you're interested, please let us know. Please let us know.
So you can have this nice 7th floor experience as a TA.
Yeah, so, and then I want to say something that I really love about this course. I feel like it's such an integrated experience. It's maybe, except project 1, everything after that is you get a piece of code as you would normally, and then everything is within your bounds of, you can do anything that you want. So I really like how it's not limited to like, oh, we're on this topic, so we're going to write a little algorithm that does implements this particular algorithm, and then move on to the next unit, and then nothing ever comes together. So that's something I really love about this course.
Great.
And the next thing I want to say is the beta grading. It's for project 3, I was working with Angela. I feel like from beta to final, because I don't have much experience with C. So it takes me so long to just get the syntax right to get my algorithm going. So for beta, we didn't have anything working. It doesn't even build. But with 2 or 3 more hours, we got it working. It's not super fast, but we kept working on it. And by the final, we have something I felt pretty proud. But the beta grading doesn't take that into account. Like if you are not very experienced with C, it takes you a long time, longer than other people who have experience to get something going in the first place. But beta kind of penalizes you for just not having enough time to do things you want.
It's a double-edged sword, because if you don't do beta, then you have very harsh. You have one time go, it goes in and out. Okay, if you just really don't give that much grading for beta and make it optional and stuff like that, people just drop beta. They don't just do anything in here.
Yeah.
So we try to do something, give everybody 2 chances, and give everybody a real motivation to actually work for both sides. Because I think for a lot of you guys, beta to final, you learned a lot. Because you got something in beta, and for most the classes I have had, we had things called checkpoints. So for example, compiler class, you had to give a checkpoint, and checkpoint will be used more like subjectively to grade. We don't say how many grades for such checkpoint, but if checkpoint has nothing, then we'll be very harsh grading late. We always emphasize that, but still, people don't take checkpoint that seriously. But here, we had to try to make something to make people get beta seriously, do something there, and then give them the opportunity to improve in there. I think there's a balance in that.
And I wouldn't worry about your grade.
well, maybe like one idea I was thinking is maybe there's some component of improvement from beta to final, like the proportional improvement that you made from beta to final.
Oh, that's a good idea. Actually, that's a good idea. To say if you made although you want to be careful about people sandbagging.
Yes.
Exactly.
Yeah. And then one last
I
small.
want to make sure we get
Okay,
to
sorry.
everybody. Okay, so if you want to go around to the end of the line.
Yeah,
go
sure.
around
That's actually most of what I want to say.
Okay, thank you.
So I've said some of this on my evaluation, which I already turned in, but I'll repeat it for everyone else. A couple things. One relating to the grading, which you mentioned. Honestly, I found it incredibly stressful knowing that it was competitive grading because we had no idea where the benchmark was. So it's like, well, we've improved it, but did we improve it enough? Did everyone else not improve it any more than we did? And it was just like having it be a complete unknown was pretty stressful. So I don't know if there's some way you could do if maybe the TAs get some speed up and that's like the benchmark to start with or something.
I guess what we did this time is basically we gave the best grade as a benchmark for the final, and if you go above that, it's just bragging rights. So
when you're working on the beta, you have no idea what's going on. I did like that. Like once you know where the benchmark is, then it's nice to know what you're aiming for.
So the thing about that is the flip side is we don't want somebody. There are a lot of courses they say, okay, I'm done. Okay, you go there something. Oh yeah, I met the thing. Okay, I'm getting a good grade. Okay, I move out. I mean, we want people to see kind of really keep pushing it. Because sometimes the thing is so. If I have a minute, I'll tell the story. There's this guy named Tony Danzig who basically invented, if you know, simplex method. His thing was he was always late to class. He went to class one day, and normally the professor write the problems in the board. So he copied the problems down and went home, and they were really hard problems. And so he was like, damn, I don't know how to solve this. And they worked very hard and solved it. And wrote a note to the professor saying, I'm sorry, this is late, and put it under his desk. And a couple of hours later, he get this excited professor running around trying to find him, because what the professor had done is written 2 unsolved problems on the board. Okay, and he came late to the class. He didn't know that. There were 2 problems. He copied it down. He worked very hard and solved them. And so he said, professor, okay, write this up. You'll get your PhD. And there's what he did. So it's something like that. So if we give the thing, if you know where you're going, for some people it would be a hard climb. But other people, they will get there faster. They say, okay, I'm done. And what we want to do is give them the ability to kind of really push to their limits, not some artificial limits, but not to penalize too much for that. I mean, we try to balance this out. So I want everybody to go to their best limits.
I had one other thing to say. Have you considered, or would it be possible to make the class more than a 12-credit course? Seriously, since there is so much material, and like we keep talking about, like, wouldn't it be nice to add this and add that? But like, I mean, I don't know about you, but I spent a lot of time in this course already, and I mean, I think it's the kind of class where you could pack 16 or 18 credits worth of material into it.
I think more realistic would be to have a follow-on.
Yeah, just try to break it into 2 classes.
To make a 2-semester sequence. I think Saman and I still feel that this, it's like, okay, that's a new development effort. That this class still, I think we feel that there's more than incremental improvement we can do to make the class teachable. For example, by introducing recitations. And so I think once, maybe after next semester, next fall, we can. But thank you, because I think that would be good. And the whole idea of the sections is to try to reduce your load. There used to be a thing that was on all the evaluations that they no longer do. This is actually before I got to MIT. They had a measure called cumes per tooling hour. Okay, so a cume is how many units of knowledge you're using in whatever measure, and tooling hours, like how hard you work. And they got rid of it because they said it was not, it was not quantitative. After all, what's a cume? But you could ignore it. Well, regardless of the fact they got rid of it, because I think that it actually was a very useful measure, even if people are subjective about it. That's our goal in the course. It's not to make people spend a lot of time and then have learned, epsilon. It's to have them, for the time they put in, learn as much as possible. And so I think that we recognize it's a lot more work right now that you folks are going through. We hope that it's rewarding work, but we hope we can do even better in terms of giving people the opportunity to learn these things.
And also we are thinking about cutting things. We always think about, okay, what to eliminate, even if we add something. It's very hard because we think a lot of things are useful, important, but something has to give. So that's the hard equation.
Yeah, we're thinking of cutting caching and parallelism.
Okay. So.
Okay, we have to hurry because we've
Yeah.
got to be out of the room by 4.
I just wanted to say that I agree that I didn't really like the way the course was graded, but I did like the material in the course a lot, so that was good. But like for one thing, the thing about the competitive grading was that it was like way more stressful than necessary. Malloc was good because we had the kind of the benchmark thing. It was a reasonable like high performance to attain, and also I didn't like the way some of the stuff was weighted. Like for example, it didn't really correspond to how much time I spent on it. Like the P-set was worth like 3 or 4% of the grade, and it took like hours, I think, many hours. And yeah, that's all.
Okay, thank you.
Okay.
There's like one thing that's pretty general about course 6, I guess, is that they're really lenient on prereqs, since like I've only been at MIT for like 3 months. So yes, I'm a freshman. So,
One
like,
freshman in the class. There we go.
I'm really thankful that Professor Leiserson, Professor Amersingi let me into the course without any prereqs. And I liked the breadth of the topics, but I think like with office hours, we could have gone a bit deeper into them. And one suggestion I'd like to make is that get the nightly builds working. Like, it was there for like one night for project 1, and then that was it.
So I decided this is my last.
Can you talk to the mic?
So this is my last term at MIT, and I decided to take things easy by not taking that many courses and TAing this course. So yeah, it would be nice to have 48-unit TA shifts too.
Thank you.
I just want to say that this was like, should I take it? Yeah.
Sure.
Okay. This was like an amazing class that I learned. I think everyone can agree that we learned like so much that is not like found in like textbooks. And what I thought was really weird is that like every little random thing I've ever read on the internet has like related to like coding, I guess, has come up in this class and like useful in this class. Like every little bit of like outside knowledge that you like take yourself has like appeared useful in this class later on. And I thought it was really cool. And related to like the hardness, I guess, that people are talking about, I think everyone came into the class like bracing for like the absolute worst, because we've heard about you guys. But yeah, we were actually, or I was actually really pleasantly surprised that like there were helpful TAs like waiting and like the G7 lounge for you, like even before office hours start. And so I was actually really pleasantly surprised by like just like everyone in the class. I feel like everyone who has like sort of survived until this point has like some sort of like magic skill that like you really learn a lot from by like working with them on like group projects. And so I was just like really inspired, and I thought it was a great class.
Thank you.
Okay, thank you.
Hi. I love the class. I've already mentioned it to you, Professor Leisterson, and everything that everybody else before me said. I just want to mention 2 things I don't think were mentioned. Pair programming, to be honest, was amazing because I worked, except the final project, everything I did was pair programming in the projects, and the amount of bugs that like we avoided because of that is ridiculous, especially when we're doing pointers, and if it doesn't work, make it a pointer, and all those philosophies that we came up with. But that's the first thing. The second thing is, and I've already mentioned this, a book or readings for this class or links, because as amazing as the lecture slides are, a lot of work done there, so thanks a lot. They're hard to connect together, especially when you're trying to figure out what our cache oblivious algorithm is trying to do with this whole data and stuff. Yeah, so that's pretty much it. Are you telling me Stack Overflow has as much as this course online? All right, well, thanks a lot again for the TAs. Most of my learning came from them, to be honest, and lecture. Hands-on learning, hands-on learning.
Yes.
All right, thank you.
Hi, my name is Harold Prokop. I'm the head of engineering at Akamai. So I wanted to use the opportunity to thank all of you for taking the class. Charles was my advisor when I was at MIT, and he told me about his plans for the class. I thought it was a great idea getting a lot more hands-on experience going. Back when I spent time at MIT, there was a lot more theory, and Scheme was one of the main programming languages. So in that context, I really like this type of class, and I'm glad MIT is investing in that and support it from Akamai. So I'm honored that we could sponsor it. I'm very happy you're here. There's, I think, refreshments downstairs in a few minutes.
Yeah, I'd also like to ask Harold to say what the topic of his master's thesis was.
Yeah, my master's thesis is cache oblivious algorithms.
So you have Harold to thank for one of the papers that you read during the term.
Yeah, it's nice that something that I did in academia is still used, and not all now practical business stuff that I do these days. But great to have you here, and I hope to see some of you downstairs. And I have to actually go into a meeting at 4 for half an hour, but I'll be back down afterwards.
Okay.
Thank you.
Well, thank you very much for sponsoring this event and giving all those prizes. Okay, now we have food.
We also have quizzes here.